So, for circles, this is our standard form of a circle. And in the standard form of a circle, H and K are your center. Notice there's minus signs here, but even though there's a minus, the H is positive. Even though there's a minus here, the K is positive. So it's the opposite sign. Remember whenever we were doing transformations, when we moved our quadratics up, down, left, right, if it was inside of the parentheses, it was the opposite way. So that still applies here. So if you have a negative 2 here, you have a positive 2 for your center. If you have a negative 7 here, positive 7 for your center. R is the radius. X and Y are variables. They are not replaced in the problem. So if I have this equation right here and I'm asked to graph this circle, then I know that the radius of this circle is going to be the square root of 4, because that's my radius squared. So the square root of 4, my radius here is 2. And then my center will be at, I'm going to use the opposite sign here, so 3. And then opposite sign here, negative 4. Alright, so if I want to graph this, I know that my center is at 3, negative 4, so 3, negative 4 is right here. And then I have a radius of 2, so I'm just going to go up 2, right 2, down 2, left 2. Whenever you draw this in, I know circles are not easy to draw. Just don't make it look like a diamond. Try to curve your sides at least a little bit. Oh, that's pretty good. Okay, what confuses you? So we use both of them right here. So whenever I see a problem that looks like this, I've got like something here with an x squared and something else with an x or y squared. I know that's the equation of a circle. So the center is at the opposite of this number is your x coordinate, and the opposite of this number is your y coordinate. It's sort of like this has been moved to the right 3, like it would normally start at 0, 0. But this moves it to the right 3. This is with the y. It moves it down 4 because everything's inside the parentheses, so it's opposite. And then our radius just comes from the square root of whatever number we have over here. Let's do another one. So and these we're not actually graphing, but we're doing the same thing with it, right? So, like, we want the radius and our center. Okay, so Jonathan, what's the radius? Okay, it is 8, because for our radius, we take the square root of whatever our equation is equal to. Okay? Luke Norman, what would the center of that one be? 3 and negative 1. You change the signs. Right. The one that is with the x is your x coordinate, and the one that's with your y is the y coordinate. Yep, and you change the sign. Alright, so we had a minus 3 here, we have a positive 3 here. And we have a positive 1 here, we have a negative 1 here. Okay? Alright, 2 is just a little bit trickier. What's the radius for 2? It's the square root of 14. We can't take the square root of 14, so we just write the square root of 14 for that. The center is even a little bit trickier. It will be at 0, positive 9. So if there is no number with your x squared, it's the same as having x plus 0 squared there, right? I think there might be a couple on your homework, because our book doesn't like to give friendly numbers. I think there might be a couple on your homework that you have to graph that are like this. So just type square root of 14 into your calculator and figure out what it is. It's going to be like 3 point something, and then just estimate whenever you go up and down. For your homework, on the quiz, I'm not going to give you any that you have to graph that have a square root. There, it'll be a whole number if you've got to graph it, because that's just too difficult to grade. I might ask you a question where I'm asking you the radius on a quiz or a test, and you might have to tell me that the radius is square root of 14, but you won't have to graph it. Okay? All right, so Jordan, for example 3, what is our radius? Square root of 484, which sounds like it could be a perfect square, and it is. It's 22. And Jordan, what's the center? It is 3, 0. Okay? All right, any questions there? All right, let's see. Look, Leah, what's our radius for example 4? Okay, if you want to do that, our answers are probably going to leave it square root. It may simplify that. So 24, what could I break 24 into? 6 and 4, which would give me 2 times the square root of 6. I don't really care whether you give me square root of 24 or whether you give me 2 square root of 6, but if it is multiple choice, they're probably going to put 2 square root of 6. And the answers in the back of the book probably put 2 square root of 6. What is the center of that one, Luke? 0, 0. Again, on that one, you would take that decimal, so Luke says like 4 point whatever it was, and you would just estimate it, so go about 4.8 up, down, left, and right from that center point. You won't see one on a quiz or a test that you have to do that. Homework may, though, because our book's not always the friendliest with numbers. Okay? All right, so for this one, we're writing the equation for each circle. Okay? So anybody want to try number 1? Gabriel? So it'll equal 25 over here on the end. Good. Good. And make sure you square it and a plus sign. And then we'll have y minus 4. And make sure you square that one as well. Yes? It does. It will always be a plus if it is a circle. Okay, so if it says write the equation in circle, it will always be a plus. If it has a minus, it's actually going to be a hyperbola, which we'll get to at the end of this unit. So it has to be a plus to be a circle. That's a good question. Okay. All right, so let's see. Jordan, how about the next one? Good. Perfect. Okay. If you want, you can make that y plus 0 squared, but it looks like you know what you're doing a lot better if you just make it y squared there. Okay. Katie, how about the last one there? We got a radius of 2 and a center at negative 4, 7. Good, and that will be equal to our 4. Perfect. Okay? Any questions on those? All right, so if they're in standard form, students usually do pretty well with that, but we're going to see some that are not in standard form. So you see there on your notes, whenever we have an equation, sometimes it's not written in standard form. And if it's not in standard form, this is how you tell if it is a circle. So if an equation's highest degree x term is x squared, and its highest degree y term is y squared, and they are both positive, then the equation is either a circle or an ellipse. So what this means is your equation, and we'll see some in a minute, so this will make a little more sense. It has to have an x squared and it has to have a y squared, and it cannot have anything higher than the square. So it can't have like an x to the third or x to the y to the fourth or anything like that. So it can have a coefficient, but if it has those coefficients, they've got to both be positive, because if they're not, or you, like if they're both negative, you could divide through by a negative and get rid of that negative, but they have to have the same sign, because if they don't, you'll end up with a minus sign in between those parentheses, which means it's no longer a circle. So they have to have the same sign, but they can have coefficients. So if the coefficients in front of the x squared and y squared are the same, it is a circle. So if you have a 2x squared and a 2x or a 2y squared, or you have a 7x squared and a 7y squared, then that's a circle, and they have to both be positive. If they have different coefficients, you have a 2x squared and a 7y squared together, then it's going to be an ellipse. That's what we're going to talk about tomorrow. Okay. So as we learn more of these, it'll be a little easier to tell the difference between them. Obviously, whatever I'm going to give you on your homework tonight is all going to be circles. Tomorrow, I could throw in circles or ellipses, because we're going to talk about ellipses tomorrow. So, I'm going to skip this slide right here because we've already reviewed completing the square a little bit. We did that for the warm-up. So, let's go over how to put the equation of a circle in standard form. All right, so we are given the following equation. We need to find the radius and the center. So to find the radius and the center, you've got to have the equation in standard form. I know this is a circle because it has an x squared and a y squared. They have the same coefficient, which is just 1, right? They're both positive, and there's nothing higher than an x squared or y squared. Plus, we're in circles, and I feel like Ms. Hyatt probably wouldn't give us something that's not a circle right now in the notes. That would make sense. So to put this into standard form, we're going to have to complete the square sum. So the first thing you want to do is you want to group your x terms together, group your y terms together, and move your coefficient or your constant term over to the other side. So we're going to kind of be completing the square twice here. Okay? So I'm going to put my x's together. X squared minus 4x. And I'm going to go ahead and put a plus blank here because I need to complete the square on that part. And then I'm going to put plus y squared plus 5y plus blank. And then I'm going to move this negative 5 right here. I'm going to move it to the other side like we do when we're completing the square. So I will just have a positive 5. Now, notice I have 2 plus blanks right here. All right? So I need 2 plus blanks on the other side. And I want to complete the square because if I complete the square, when I complete the square, what happens is this is like, I'm going to have the x here, right? What do I do to get this number here? Divide by 2. So I would get minus 2 right here. What do I do to get this number that goes here? Square it. So I would get 4, right? And see how this looks like the standard form of a circle, x minus 2 squared? So that helps us out here. If I add 4 here, I have to add 4 to the other side. Yes. 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 And since we just need to get it in standard form, we're not like solving it all the way like we did with our completing the square. With completing the square, once we got it completed, we take square root of both sides and do all those things. Here, all we've really got to do, like once we do this next part, so I will have y. What do I do to get the number that goes here? Divide by 2, so that's going to be 5 halves. What do I do to get the number that goes up here? Square it. 25 over 4. So I've got 25 over 4 here. And so once I can get this all together, I'm just done, right? It's in standard form. I just need to tell the radius in the center. So I do have a fraction here. This is going to be 9 plus 25 over 4, which is like 9 over 1. Multiply by 4 on top and bottom. So 36 over 4 plus 25 over 4 is going to give us 61 over 4. So 61 over 4. Okay, so now I have this equation in standard form. Any questions so far? Yep. Okay, so let's see. Christian, what is the center of this? Mm-hmm. 2 and negative 5 over 2, right? That's our center. Good, and let's see. Shane, what is our radius? Good, and can we take the square root of 4? It is 2, so let's go ahead and do that. So we'll have square root of 61 over 2. Okay, questions? Yeah, 36 plus 25 is going to give you that 61. Yeah. Okay? All right, let's do another one. Okay? This one's a little bit trickier because we can't complete the square when we have a number in front, right? So the first thing we want to do here, Jonathan is right, we need to divide everything by 2, which at least everything will go evenly, right? So we will get x squared plus y squared minus 2x plus 6y minus 9 equals 0. Yeah, you've got to keep going with it, even if you get a fraction, and you may on some of the more difficult problems. I don't think there's too many that you get a fraction in the middle, but it can happen. So you would keep going. Now we will see tomorrow with an ellipse where these two don't match. We're going to have to do something different. But today, for it to be a circle, the coefficients have to be the same. So you're dividing by whatever that coefficient for your squares is. Yes. Okay, what do we do next, Katie? Perfect. Perfect. Okay, so Katie, for that first one, we know we'll have an x. What do we do to get this number here? So what do we get? Good. Positive or negative? Negative. It's always going to be whatever sign you have here. Good. And then what do we do to get this number? We square it. Good. And what do we get when we square 1? Just 1. Right. So if we add that here, don't forget to add it to the other side. I always put my blanks there because if you don't, it's really easy to forget that you got to add something to the other side. And then for the next one, Katie, we've got y. What will go here? Good. So we'll have a plus 3. And we'll put a 9 here. So we'll add a 9 over here. Oh, look, we don't even have fractions on this one. This one's better. So this is going to give me 19 here. So I've got it in standard form, right? Let's see. Brian, what's the center? Good. And what would the radius be? Perfect. questions there? All right. Okay, here's our next one. Yep. $17. Okay. Then we need to group them. Squared minus 10x plus blank plus y squared plus 4y plus blank equals negative 17. So we will have x minus 5. We will square that 5 to get a 25 here, so we'll add 25 here. Then we will have a plus 2 here. We will square that and get a 4 here, so we've got to add 4 here. So see, that gives us 29 minus 17 is going to give us 12. Okay. So Jenna, what's the center of that? 5 and negative 2. And let's see, Levi, what's the radius? It is the square root of 12. Will square root of 12 break down? 3 and 4. So that would give us 2 times the square root of 3. Just for practice, as you do your homework, go ahead and try to break those down for me. I think your answer key's probably going to have them broken down there. Plus, it's just good practice there. If they will, like square root of 19 on the last one wouldn't break down. Okay, any questions? All right, your homework is there. That is correct on the page there. So these are the problems that you have. I skipped a few that the book has sort of like, they're asking you to graph something with a square root. There might be a couple there, but make sure you graph the ones that say to graph.